Good morning, everyone, and welcome to today's webinar for World Space Week. And we are going to be looking at how we can tackle climate change from space. I'm going to wait for a minute to let people join the event. I can see we've got quite a few people joining us already, but I'll let a few more people join before we get started. Whilst we wait, you can have a look at my virtual background, this picture behind me. Have a look. What can you see in the picture behind me? Have a think to yourself. Maybe you've seen something like this before, and I will tell you answer in a minute when we get started. Welcome to this World Space Week webinar. My name is Vicky and I work for RAL Space, and we are the UK's National Space Laboratory. So we help to design, build and test spacecraft and get things ready for space before they're launched into space. So you might know of spacecraft that go into space to look at other planets or to look at the sun, or even to look further out into space to other stars and galaxies. But satellites that orbit Earth are also very important for looking back down at Earth so we can explore our climate and our environment. And this is especially important now. So that's what we're going to be exploring today, how we use satellites to look at things like climate change. So before I introduce our topic and introduce you to our speakers for today, you'll be meeting some of the women who work in the space industry. I have 3 quick multiple choice questions to help us find out a little bit about you and who's watching us today. The first one is how many people are watching in your group or in your classroom today? Your second question, we would like to ask your class to raise their hands and tell us, do they think that space is for everyone? And after this, we will have one final question, and that is, would you like to work in the space industry? So again, everyone put their hands up, yes or no, or maybe, would you like to work in the space industry in the future? All right, so let's learn a little bit more about RAL Space. So as I was saying, RAL Space helps to make satellites that observe the Earth. Satellites are launched into space a few hundred or a few thousand meters above our heads, and they orbit around Earth. So they stay at about the same height above the Earth's surface and they move around. And they can send back lots of information. So they could take some pictures and they can send back this data to us. And that could be things about the weather. Or if we look at the weather over a very long period of time, that's called our climate. So what we do is we collect all of these data using satellite dishes. And that is what is in the picture behind me. So well done if you got that correct. These are satellite dishes, or antenna, you can also call them. So you might have a smaller version of one of these dishes on the side of your house, and that picks up your TV signals. Have a look if you go home tonight, if you can see it on the side of your house. So these ones are much bigger versions. They're a few meters across, and our biggest one is 25 meters across. And these pick up satellite signals. So I'm now going to show you one of the satellites that we use. So this is called the Sentinel-3 satellite. This is a family of satellites, the Sentinels, that we've helped to design and to get ready for space. You can see there it's above Earth, flying above Earth, and one of its jobs is to look at the land and the oceans to measure the temperature, how hot or cold these are. And that's very important for looking at things like global warming and seeing how the climate is changing. And we can do this from space, and it's very good to do this from space because when you're so high up, you can look down and see a much bigger area. And because the satellites are moving around Earth, it's also easier to see the entire planet in a shorter space, in a shorter time frame. So that's why we can use satellites. And this is one of the ones, as I said, that we actually help to design and to test in our facilities. And I'm now going to show you a sneak peek of a virtual tour that we have of our facilities. So this is now available online, and we can share the link afterwards as well. It's brand new, and I'm going to show you a sneak peek of what our facilities look like and where we work. So it might take a moment to load on your screen, but you should now be able to see the front of our building. It's quite a new building. It's quite big and shiny. It's got big glass windows at the front. And inside this building, we have all of our offices where I work normally, and we are based just south of Oxford in England. And it also has all our labs as well. Now, I should say, RALSpace has been around for about 50 or so years now. We've actually been around for quite a long time, and we've supported over 210 space missions or projects. And we are very big on teamwork. So in the space industry, you might have heard of NASA, the space agency in America. There is also ESA, the European Space Agency, who we work very closely with. There's also the Canadian Space Agency, Japanese Space Agency, lots of different organizations that we work together to make a space mission happen. Lots of different people with lots of different skills. So this is the outside of our building, and I'm now going to show you inside one of our labs. So when we send something to space, it's quite difficult to change anything once it's in space. So for example, if something breaks, it's not easy to fly up there and fix it. So we make sure that we test that everything works first. So we get it right first on ground. And that's what we do inside our labs. So I'm just going to change room to go inside one of our labs. Again, this might take a couple of seconds to load onto your screen. Okay, so this is a space test chamber. It's quite big. You can see the people there at the front for scale. That's actually me there at the front on the left. So you might know space is a vacuum. There's no air. And this also means that it can be very, very cold in space or very hot when you're facing the sun. So what we do to make sure that our things will work in the environment of space is we put our equipment inside this chamber, we shut the doors, and then we pump out all of the air to make a vacuum. We can then use all of these panels, the black panels around the edges, to control the temperature, how hot or cold it is, and we can do this very accurately as well. Then we plug in our spacecraft and we test that it works as it should do. So that's how we test our spacecraft. We simulate space, we pretend that we're in space. And we also have to wear these special suits you can see at the bottom, these clean room suits from head to toe. We have hoods, face masks, hair nets, big boots as well. And that's to make sure we don't contaminate the equipment, we don't get it dirty, because humans, we can shed hair, we can shed skin, we can shed nails. So we make sure that nothing falls off us and doesn't get our equipment dirty. Because again, once it's in space, we can't just go and wipe something off if it's a camera, for example. So that's a sneak peek inside our chamber. And also just to tell you, this can go down to about minus 180 degrees Celsius, very, very cold. Or it can go to as hot as plus 150 degrees Celsius. So very, very hot. So as I mentioned, this tour is now available online. You can go through and you can actually open these people little buttons there, and you can meet some of the people who work for RALSpace. And that's what we're also going to do today. So you can have a look through this tour yourself, but I'm now going to introduce you to our speakers. First of all, we have Kat. Kat is an engineer for RALSpace, and she's going to tell you all about her work. So when you're ready, over to you, Kat.
Thank you very much, Vicky. So as Vicky said, I'm an engineer at RALSpace, and today I'm going to talk to you about cloud spotting from above. So as Vicky said, we design and build instruments to go into space. We also get them ready for launch too. So today we're going to talk about that. I'm going to tell you about that. So first of all though, a bit about me. So I had no idea what I wanted to do when I was at school. So it was absolutely a-okay not to have a plan. All I did know is that I liked science. I really liked learning. So when I got to the end of my A-levels, I decided I'm going to carry on learning and I'm going to do something I enjoy. So I went to university to study physics. And this is me at university graduating with some of my friends after we'd finished our degrees. And then I still didn't know what I wanted to do. So I had a look around for lots and lots of all the jobs that I could potentially go into. And I decided to have a go at engineering. So I joined an engineering company and that was really good. I really enjoyed it. But then I thought to myself, what do I want to design and build? So engineers design things. And I thought, what do I want to be designing? I really, really like space. So I had a think and I thought, I really want to be designing stuff that goes into space and helping things go into space. So a couple of years ago, I joined RAL Space, and that's how I got to where I am. So I didn't have this big master grand plan. I just did what I liked, and that's got me into where I am in a job that I really enjoy. So don't feel like you need to know exactly what you're doing. Okay, so over the next few minutes, I'm going to talk to you about weather satellites. So how do we measure climate change from space? One of those ways there is a group of satellites that look down on the Earth and measure the weather. And one of those things they do is they look at the clouds. So as Vicky said, America have NASA, and it's not just America that have their space agency. The space agencies all around the world. So we have the European Space Agency, or ESA, and they are making they made these satellites. So we have our weather forecasts. These satellites are currently going over the planet, and they go over the planet in a polar orbit, which looks like this. So they go round and round the poles. And it takes about 90 minutes for them to go round the Earth once. And while they're doing that, they're looking down and they're looking for clouds. And then they ping back that information to the ground on one of those satellite dishes that Vicky showed you. And that means that we know where around the world clouds are, where they're moving to, and we can get our weather forecasts, but also we can collect all of that data and analyze it over time. And that gives us information on what the climate is doing. So these satellites are pretty old now. So this one was launched in 2006, which is quite a long time ago. So at the moment, this is what this satellite is doing. So this instrument here is the one that's looking at the clouds, and it's spinning around, so it's scanning the Earth. So here it is on the bottom of the satellite, so it's looking down and scanning. And you can see this is just to show it's scanning across, so it's spinning around and scanning the planet. So there it is, looking at this cloud, building up a picture as it's going over. And what that picture ends up looking like is this. So it's flying over the Earth, scanning all the time. And this picture, these lines are 16 kilometers long, which is just like 160 football pitches. They're really, really, really long. You can see it's covering the whole of the United Kingdom. So those satellites have been up there for a really, really long time. So we need to replace them because they're getting old, and we have got better technology that we can put up there now to look at the Earth. So for the second generation, before we only had one satellite that was looking down on the Earth to measure the weather. Now we're going to have two. So there's going to be lots more instruments up there. They're going to look for lots more things. We're going to gather lots more data and learn a lot. So these haven't been launched yet. The first launch date is due for early 2024. So we've still got 3 years before we are going to launch these satellites. So they're still on the ground being tested. And this is the bottom of one of them. And as you can see, there's an instrument on it that looks a lot like the one that we just saw. So there's this instrument here that has this mirror that does spin round again to take us to look at the Earth. And that is also looking for clouds. So that's really great because it means that the old satellite was looking at clouds and gathering data. The new one is doing that, which means that we can use the old data and learn all that stuff in the past and see how it's being affected in the future, how things are changing. So this is what the new one will look like as it's scanning the Earth. So as I said, these satellites are not in space yet. They will be launched in 2024. And here at RAL Space, one of the things that we do is we test the instruments to make sure that once they go up into space, they work like we need them to. Because as Vicky said, once you're in space, if something's broken or you haven't done something right, you can't go up there to fix it. The AA or the RAC, there's no breakdown cover up in space. So we need to make sure that things are absolutely right before they get launched. So this is a photograph that I took last week. So this is hot off the press of the instrument, which you can see in the middle of this rig. And then here is that mirror that spins round. So this will go on the bottom of the satellite. This is our test equipment that we have built. And the instrument looks at these two shiny things and makes sure that what it's seeing is what it's meant to see, and it knows. So we'll turn the instrument on, we'll look at into these shiny buckets, and then we'll see what the instrument's seeing and see whether it's working properly. So this is in our clean room. So to be in here, we have to be dressed, as Vicky said. But we actually test the instrument in our chambers. So this is a slightly smaller one than Vicky showed, but it's still, you can still get in it and stand up. It's still really, really big. So it goes in here, then we close the door, and then we make it like it pretends that it's space. So we suck all of the air out of this chamber, and then we make it really, 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 really cold. Sometimes really hot, because if things are facing the sun, they get really, really warm. And we test it in everything that it's going to it makes it think it's in space. So when it's being tested, it will work exactly like it does when it's in space. So then when we launch it, we know it works properly. And this was us last week wheeling it into the chamber. Okay, so thank you very much for listening. I hope I've given you a small insight into how we observe the weather from space, and one of the instruments that is going to look at clouds and made you excited for what we do on Earth as engineers to get it ready for being launched.
Thank you, Kat. That was really, really interesting, and really interesting to see this is happening right now. This is one of the projects that's going on right now, and that will be launched in a few years' time. So when the images come back to Earth, you'll be able to see them and you know where they've come from. So thank you very much, Kat. If you've got any questions for Kat about what she does, about her job, or actually what she did in school and how she got there, do type them into the Q&A box and we will ask her those questions at the end. Okay, so we have talk number 2 in a second. And after this talk, we will then be doing a short activity as well. So now I'd like to introduce Kate. Kate is an environmental data scientist, and she's going to explain what that means and what she does and how she also helps look at our climate from space. Okay, over to you, Kate.
Hello everyone. So my name is Kate and I'm an environmental data scientist. So what do I do? So I collect information about the weather and climate from around the world. So this can be data collected from a weather balloon, and hopefully now, yes, we can see one now on the slide being released. So did you know when a weather balloon is released into the sky, it expands to the size of a double-decker bus? It collects information about temperature, so how hot or cold the air is, the air pressure, so how heavy the air is, and how much moisture is in the air. So there's usually a lot of moisture in the air just before it rains. So I can also get data from aircraft and planes. So one of these is the UK's Adapted Atmospheric Airplane called BAM. And that we can see that in these photos. So it may look like a normal aeroplane to you, but if you take a closer look, you may be able to see some additional instruments hanging off the wings and the body. So it measures different temperature, the wind, it can measure all different air pollutions as it flies through the sky. And inside, all the seats have been stripped out and racks of laboratory instruments have been installed, and there is just room for a few scientists. It is very noisy inside with all the instruments working at the same time. Also, in one of the pictures, you can see that the aircraft is flying very low across the sea, and usually aircrafts don't fly that low, but this is a special aircraft and has permission to fly really low, and it can get down to about 50 meters from the sea, and it also can fly really high. So another example of data I can get is air pollution, and I also can get data from weather forecasts and models, where a computer has simulated what might happen, and weather forecasters on the news share this information with us. I think we've all seen the weather on the TV. And also Earth observation data, such as satellite images. So we use all these data to monitor the Earth. We can detect and monitor weather patterns, ice sheet movement, sea level rise, ocean temperature, carbon dioxide levels, animal migrations, and human development, plus lots more. We can look at specific places and cities for local changes or problems, or look at entire continents to see the big picture and how everything is connected. So the data that we gather from around the world gets processed and stored onto a big supercomputer called Jasmine. There we go, and we can see Jasmine in this slide here. So Jasmine, the archive, is about 22 petabytes big. So let's just figure out how big that is. So an average smartphone has a memory of 100 gigabytes. So for example, an iPhone. So Jasmine is the same size as 220,000 smartphones. So that's 220 with 3 zeros on the end. Now we take a closer look. So a good photo on a smartphone, maybe a selfie, because I know we all like taking selfies, usually is about 5 megabytes in size. So on Jasmine can store 4 billion selfie photos. So that's enormous. So if we imagine the scale of a real objects to compare them, let's say a smartphone storage, which is 100 gigabytes, is the same size of a guinea pig, around about 100 grams. Then the archive will be equivalent to 3.5 elephants, which is enormous. So we can get images and data daily from satellites orbiting the Earth, such as the Sentinel ones looking down on the Earth. And we can see an image of one of the Sentinel satellites gathering the data. And it's my job to get the data from the scientists into the archive by checking the data formats and sending the computer code and commands. So Jasmine allows scientists from across the world to access the data and work to find out what is happening to our planet and inform politicians or people who make decisions about how we tackle climate change. Most recently, I worked with the team that published the IPCC climate change report, the big report that was on the news in August, and most of you might have heard about it. For my job, I use skills such as communication. So when I speak to scientists all around the world, I need to communicate to them. I also use attention to detail and accuracy when checking the data and putting it onto the supercomputer. Additionally, teamwork and coding are key skills. Using coding to tell the supercomputer what to do and where to put the data. If I don't give the computer the exact instructions, it won't put the data exactly where I want it. So where did my journey start? My journey started at school when I really enjoyed geography, learning about the weather and volcanoes and the Earth. And I'm currently watching the volcano eruption in La Palma in Spain and tracking the extratropical cyclone Sam that's currently in the Atlantic Ocean. I also studied a range of subjects such as maths, music, food, French, ICT and science, which helped me to learn other useful skills such as analysis and attention to detail. I then went to university to study geography, and I did a year in industry at RAL Space. And after I graduated, I came back to RAL Space as an environmental data scientist. Outside of school, I played the clarinet in many different bands, and I also a Girl Guiding member, where I was a brownie, a guide, a young leader, and now currently a brownie leader, which has helped develop my self-confidence. So I hope you all enjoyed listening to my talk. I'm going back over to Vicky.
Thank you, Kate. That was really interesting as well. So an environmental data scientist is looking at all the information from all the different satellites and different places that we can get information and sharing it across the world so we can learn more about our planet. I also thought it was really interesting to hear about your different experiences, learning lots of things in school, but also the activities outside of school and the different skills you can get from those and how it can help you decide what you would like to do in the future. But equally, as Kat was saying, there's lots of different routes and you don't have to know what you do, and you can also change your mind later on. So thank you very much, Kat and Kate, for their talks. Do keep sending in your questions. We've already got a couple coming in, and I will read them out later on as well. And we'll have some more time at the end as well for you to actually type in your questions. Okay, so now we are going to move on to our activity. And what we are going to do is look through some satellite images, and you're going to have a go at exploring the Earth from space. So I will go through all the questions, and these images were all taken by the Sentinel satellites, which we've mentioned a few times already. And these are the ones that monitor and look at the land and the oceans, the weather in the atmosphere, in the air around us. So what I will do is I will show each image. I will give you a few moments to have a good look at the image to take it all in. Then I will read out the question, and it will be multiple choice. So there will be one correct answer. So let's see how many questions we get through. So the first image is this one. And I will let you have a good look first of all. You can see lots of different colours there. And you can see the different perspective. So if anyone's ever been on an aeroplane and you often go up through the clouds, the view that you have is then looking down on the Earth, a bit like a bird's eye view. So my first question for you is, what can you see in this picture? Is it a mountain? Is it a hurricane? Or is it an ice cap? So I'll give you couple of minutes to have a look and send in your answers. Or if you want to write it on your sheet in front of you, you can do that as well. And then you can mark your answer. Lots of answers coming in already. It is quite tricky because it's a different perspective. It's a different view of Earth from what we are used to. Good, most people have given us our answers already. I'll give you another few seconds to answer. Okay, so let's reveal the answer. The answer is a hurricane. Well done if you got that correct. And let's have a look. So this big white area near the top right, that's all cloud. So that is a big storm. And you can see it's in a spiral shape. It's moving around in a circle. And there's also a little central point, a little circle in the middle, and that's the eye of the storm. So this is a hurricane. Very well done if you got that, but don't worry if not. As I said, it's a different perspective from what we're used to. And sometimes, as I think some people thought as well, it is white, so it could also look like ice. But you can see the texture is quite fluffy. So in this case, this was clouds, part of the hurricane. Okay, let's have a go at question number 2. So your second question, or your second set of pictures, is this. So we've got 2 pictures here, and this is of the same place. This is Dubai in the United Arab Emirates in Asia. One image is from 1999, so probably before you were all born. And the second image is from this year, from summer this year, just a couple of months ago. And you can see this has got a coastline. So we've got some land and we've got some ocean there as well, the sea. take a good look at these images and spot the difference. What has changed over time? So my question for you is, are there now more man-made islands, or has the city become smaller? Have a good look, and I'll give you a couple of minutes to answer this. I can see some correct answers coming in already, but I'll reveal the answer in a few minutes. All right, I think I'll give you another 10 seconds. Okay, thank you very much for your answers. I think everyone who submitted it got it correct. So there are now more man-made islands. So let's have a look at these pictures in more detail. So in 1999, you can see a lot of the land was this sort of orange yellow colour, and that's because it's a desert. So there was lots of sand. Now, this year, you can see there's more grey colour, and that's because there are more buildings and more roads because the city has got bigger, so it's not got smaller. But we can also see, if we look in the ocean now, there are also more things in the ocean. There's more shapes in the ocean. And that's because these are man-made islands. You can see this one in particular is shaped like a palm tree. And that's a very specific shape. So this wasn't natural. This was made by humans. And this is just an example of how humans shape the environment around us and how we can change our environment. So very well done on that one. And let's go to question number 3. So these pictures are slightly different. I'll just zoom in slightly for you. So these ones aren't like normal photographs. The colours are actually showing the amount of air pollution. And this is quite important because air pollution is not good for us. It's not good for us to breathe in. It's better to have clean air to breathe, and that's healthier for us. And air pollution can be made by having too many cars on the road, for example. So if we're thinking about being sustainable or environmentally friendly and making good choices for the environment, it's often good to look at using electric cars or actually walking or cycling to school or to work. So what these pictures show is areas of pollution. The red and green areas show where there is more pollution. And the top images are before lockdown due to COVID-19. And the bottom picture is during lockdown. So my question for you is, was there more pollution before or during lockdown? And I'll zoom in slightly for you as well, so you can have a look. Zoom in on the before image. And then I will scroll down and have a look at the image during lockdown. Okay, and I'll zoom out again so you can see both of them. Ooh, there we go. Lots of answers coming in on the chat. Good to see. I'll give you a couple more seconds to have a think about that one. Wonderful. Okay, so I think a lot of you have got this one correct. There was more pollution before lockdown. So let's have a look in. You can see if I zoom in on the image before, there were more red and green areas. And you can see this across America, across Europe, across Asia, across all parts of the world. So well done again if you got that correct. And we can have a little think about this as well. So Why was there more pollution before lockdown, and why did it actually decrease during lockdown? So if you remember what I said before about cars, and that a lot of cars and the fumes from cars can cause air pollution, when we went into lockdown, we had to stay indoors. A lot of us couldn't go to work or to school. So people stopped traveling, stopped using their cars. Fewer cars meant less pollution. So that was why pollution actually went down during lockdown. Okay, let's move on to the next question. So this again shows pictures from space. This shows the UK, so you might recognize this one. It goes from, we've got Scotland at the top, we go down through England to Wales, Devon and Cornwall just chopped off at the bottom, and Ireland over on the left. So we've got a normal picture there, a normal photograph, and then the picture on the right is actually a heat map. It shows how hot or cold the land is. So my question for you is, what colour do we use to show the hottest areas? Is it red or is it blue? Just give you 10 more seconds. Okay, well done everyone who answered the poll. The answer was red. So we can see on this picture on the right hand side, most of the land is red, and that's where it's hottest. And then out towards the edges, it's quite cold. So typically around Scotland, very cold, also there, and the Northern Ireland as well, it's quite cold. And that's quite common in satellite images, that we can use different colours to show different things. So we think of red being quite hot and we think of blue being cold. So we can show this and use colours, and it's called false colours. So false colour images, and that's what we often do on satellite images. Very well done. Okay, let's move on to our very last question. And again, I will leave this on screen first for you to take it in. Have a good look at this picture. You can see it was taken on the 9th of September 2020, so just over a year ago. And my question for you is, what can you see in this picture? Is it a volcano? Is it a snowstorm? Or is it a wildfire in a forest? Can give you a hint. Remember, we were talking about red, showing areas of hot areas, hot land. All right, just 10 more seconds. All right, excellent. Well done, everyone. This was quite a tricky one. The correct answer is, this is a wildfire in a forest. So I know a couple of people also said volcano, and I can definitely see why you would think that as well. But let's have a look at the picture. So you can see a lot of the areas are green, and this is showing the trees. So this is showing the forest. And then you can see all the red areas. This is where it's very hot and shows the points of the different fires. And there are lots of different areas of red. So there's not just one source of heat like there would be in a volcano, but in the fires, there's lots of fires. And it being a wildfire, it's quite expansive, it's quite big. And you can see the smoke trails. So that's what the grey sort of white parts are. That's the smoke coming off the fires. Very well done there. You've got the worksheet and we've emailed that to you as well if you want to have a look back through it, and the answers as well are there, so you can have a look through. So very well done. And if you are interested to carry on exploring space, exploring Earth from space, there are lots of satellite images online that you can have a look through as well. Okay, so for the last part of today's webinar, we will have our Q&A session. So I would like to invite Kat and Kate back onto the screen so we can answer some of your questions. So now is the time. If you want to type them into the Q&A box or into the chat, you can do that as well. And we will get through as many as we can. Okay, so let's start off with, ooh, what's a good question? Ooh, I have one for you, Kat. So Kat, you were talking about satellites that we help to make and to test. Do you know how many satellites we have made this year? And that was from Mia.
That's a great question. So we have lots and lots of projects going on at RAL Space. So it's not just even though I feel like my project is the most important, there are lots of projects happening. I don't know how many we've done this year, but I do know that over the 50 years of RAL Space, we have been involved in over 210 space missions. So we do work on a lot of space missions. They are big events, you know, it's a big thing launching a satellite. So we don't throw them up there, that we do a few at a time.
Yeah, so we do a lot and it varies from year to year. We can work on some small satellites. So if we do those ones, then we can do a lot in a year. Or if they are big satellites, then we would spend a lot of time on them. Okay, let's have a look at some of the questions. Kate, this one's for you. This was from a year 6 class. What is your favourite or most interesting part of space?
Oh, that would have to be tricky because there's a lot. I would have to say my favourite part is actually looking at when the satellite images come through to the archive. Because everyone comes through is different and you can see all different things.
Yeah, satellite images are quite pretty, I think, as well.
Yeah.
And when you can see lots of different things, that's really cool. Wonderful. All right, Kat, back to you, also from year 6. Why are satellites the colour that they are? So what different colours can satellites be?
So satellites can be lots of different colours. What we mostly do is, can you remember when I showed you the picture of our test rig and it was really shiny? And it was almost like we'd wrapped it in aluminium foil. Well, that's we wrap satellites a lot in this kind of like foil because it could be really, really warm in space if you're staring at the sun, and that protects it. But it also can be really, really, really cold. So that foil also acts as like a blanket. So it's very, very good stuff. So satellites tend to be like kind of a shiny silver.
That's really interesting. Actually, some of the people that work at RAL Space, they make this by hand as well. So our technicians are very skilled. And a couple of people in the team, they didn't do sciences. They actually had crafting businesses. So some of them used to be dressmakers. Now they use their skills to make these space blankets, which I think is a really cool way of getting into the space industry as well. All right, let's go on to the next question. How many people are there in RAL Space? So I can answer this one. At the moment, we've got about 330 people in RAL Space, which is a lot of different people, lots of different skills. So it's not just all scientists and engineers. We've got our communicators, we have our technicians, we have project managers, people with leadership skills to bring the team together and make sure we're working on time and to budget as well. Okay, let's have a look at, Kat, maybe you can help us with this one. This was from Westley School. How does it feel to be in the chamber when you're working there?
How does it feel? I mean, it's really cool. You feel really like, whoa, is this my job? Like, this is really awesome. You are also a little bit scared because, you know, people have put a lot of effort into making this instrument and you don't want to like fall over and break it. So yeah, I get quite kind of like, I've been here for a couple of years now and I'm still like, oh my goodness, is this my job? It's really cool.
Just to follow up on that, how long does the testing process take?
So we're going through testing at the moment. And so we're testing just the instrument. So first of all, you have to test the individual instruments. And that's taking us, just for our test, about 2 or 3 months. But there are lots of different tests. So we're making them look at those shiny things to make sure it's working properly. But we also do tests where we shake the instrument as well. And that can take a few weeks. We do tests where we heat them up to make sure that they're going to survive, like getting really, really hot if they look at the sun. There's lots and lots of testing. The testing normally takes years, like 3 or 4 years. And then they build it all into the satellite, all of the instruments, and then they will test the satellite as well. And so the satellite will go through all of that testing, because when you put something on a rocket, you can see when the rocket is being launched, it's shaking, there's loads of fire coming out the back. So we need to test all of that to make sure that it can get up there safely. And then once it's up there, that it can work okay up there as well. So yeah, great question. Testing is very important. It takes a very long time.
Great. Thank you, Kat. Okay, let's move on to Kate. So a question for you. Why do you have to record the weather from space? Can't we do it from Earth?
So we record the weather from space because our satellites can look down on Earth, and then we can see what is actually happening and what's moving it around. Whereas if we do it from Earth, we can't see what is above us. So it's easier to go up to space, and then we can see a bigger, wider picture of what is actually happening and what is heading our way.
But we can do it from Earth, is that correct?
Yeah.
When you mentioned the plane that goes quite low to near to the ocean, so we can do it from Earth, but it gives us more information from space, is that correct?
Yes, a lot more information, and the airplane can only fly at certain times, so it's not going to be flying all the time. So we need to be able to get a perspective of what's happening all the time.
Yeah, really, really interesting. Thank you. A question for both of you. What is the hardest part of your job? Kate, do you want to go first?
Yeah, my hardest part of the job is trying to solve some code. When you put some code together and you think it's going to work and it's going to go straight in the archive, and you've checked it all, and then it doesn't work. And you've got to figure out why it doesn't work. And it can take absolutely ages. And then sometimes the next day you realize, oh, it was just a spelling mistake or something like that. And that's
literacy skills is actually really important as well.
Yeah. So yes, or you just got one tiny little word wrong, one part of the command wrong. But yes, that is my most frustrating part.
I think it's really hard when you do a test and it doesn't quite go right. Sometimes we do tests and we don't get the answer that we want. And then you have to make really difficult decisions. Like, do you try to fix it? Or actually, are other instruments waiting for you? And maybe you don't get to do everything that you want to do. And then you have to it's really difficult to make those choices because you want to make the best thing that you can. And sometimes it's really hard when you think, oh, this didn't work out and we're going to have to maybe not do something. So I find that very difficult.
Yeah, that is quite difficult. Yeah. Just a little bit about your routes to get to RAL Space. We had a question from Miss O'Neill's class. What universities did you go to? Kat, start with you.
So I went to Durham University, which is really, really far up north in England. And I had a great time. It was a wonderful university and I really enjoyed it. But it's one of those things where wherever you go, you'll think it's the best place you could have gone.
Yeah, and I went to Coventry University, which is based in the Midlands, and I had a fabulous time, really enjoyed it too. I mean, you have to pick a university where you feel comfortable and where you know you're going to enjoy it.
And of course, you don't have to go to university. There are lots of other routes. As we've said, you could change job much later in life, or you can do apprenticeships. And apprenticeships can also be really, really valuable to get work experience. So you can work, you can have a job at the same time as doing some studying as well. So there's lots of different routes. Okay, next question. We've got lots of questions coming in, so we'll try to answer a few more. So I think I saw one that was asking about, do we send satellites to other planets? Kat, can you answer that one?
So we do send other satellites to other planets in our solar system. So, and sometimes we put stuff on the planets as well. You know, we send things to Mars and then we land stuff on Mars, and it, you know, the rovers, and they go and trundle around to find out things. So we've sent satellites to have a look at Saturn and Jupiter. We sent a satellite that kind of flew past Pluto and had a look on its way. So we can't, planets outside of our solar system that don't go around the sun are a bit far away. We do look at those. So we still put satellites up with instruments that look at those planets, but they're a bit too far to send something at the moment. Maybe one of you will send something there.
Oh, definitely, yeah. One question I've seen as well, just to explain. So RAL stands for Rutherford Appleton Laboratory. So that's what we stand for, and we're based in Didcot, just south of Oxford in England. Okay, next question as well, from Bolshaw Lane Primary School, and I think I've seen a couple of people ask the same question as well. How do we get satellites back down from space? Or if a satellite stopped working, or if it was broken, how would we get it back to space? What would we do? Or if something goes wrong, have you ever done anything wrong? What happens?
So there's a couple of things that happen once a satellite that could happen when it gets out of its life. So we do sometimes, you know, they're flying above the Earth, and once they're done, you know, they're either stopped working or something's gone up to replace them. We'll crash them back down into the Earth. And obviously we make sure that we don't crash them into where any people are. So often we'll crash them into the ocean and then scoop them up. But sometimes they do get left. And it's a big problem at the moment, where there's quite a lot of space junk that's out there floating around. And it's a problem for the future of how are we going to clean space? Because we want to put more stuff up to make more discoveries, but it's getting a little bit crowded right now. So it's a problem for the future. How are we going to go and gather everything that's stopped working or is broken and bring it back down to make sure everything's clean?
So maybe that's a problem that you could help us solve in the future. And just to say, we do actually track all of the satellites using these dishes that are behind me. So we can track all the space debris. And some of it's very small, but some of it is whole satellites as well. And that's a problem you could solve. Okay, we're just coming to the end. So I think I'll ask one last question for Kate and one last question for both of you, or two questions for Kate, if that's okay. So from Miss O'Neill's class and Tommy, why do you call it a supercomputer?
Oh, it's called a supercomputer because it's a lot more powerful than your normal computer or laptop. I showed you how big it really is, and that's why it's called a supercomputer.
Great. And also, is the weather balloon like a party balloon but bigger?
Almost. So it has got an instrument at the bottom of the balloon, and I believe it's made out of different stuff. I think it's made out of latex mainly, but yes, it is filled with helium, and it's a lot bigger.
Great. And a last question for both of you. Have you ever been to space, or would you like to go?
I haven't been to space, but I'd love to go and see the views. Yep, I'd love to go.
I haven't been to space either, and equally I would love to go when, you know, space tourism, that kind of thing. I'll let a few other people go up first as a space tourist before I go, but I would love to go eventually.
Great. I would also love to go as well if I could do. Thank you very much for all your questions. We had so many questions. What I would suggest is you can keep in touch with us on email or on Twitter as well. And we will send an email after this to give you our contact details so that you can keep in touch with us. So I hope you all found that really interesting. And we are going to share a poster of information so you can find out even more about climate change and about space, how we study the environment from space, and also what jobs you could do in the future to help us solve some of these problems and also continue to improve things and help us solve or tackle climate change. And we will also have another activity link to share with you. We have an online activity called Cloud Catcher. So as Kat was mentioning, we look at things like clouds. Sometimes clouds can get in the way as well. So what we have is an activity called Cloud Catcher, where you can look through satellite images and catch the clouds. You can do this online, you can do it at home if you wish, or in school, and it's really useful for us. So you'd be helping us, you'd be helping our science and doing some real science if you can do that as well. All right, so I have 2 final questions to ask you in the polls. So I'm interested, again, teachers, if you could very quickly help us out with this one, to ask your class, after watching this webinar, do you think space is for everyone? And I'll give you a moment to answer that. Lots of yeses, that's really great to see. And then the very last question, would you like to work in the space industry? After watching this webinar, do you think you'd like to work in the space job? So I'll leave that poll open to the end so that you can give us your answers. And I'd just like to say that I hope you've learned something new today and seen that there is a huge variety of jobs to do with space, how we make a space mission successful, and lots of different projects. Also, Kate using skills to look at the images afterwards and store all of that data and share it with lots of scientists around the world. And hopefully you can see maybe you could do a job in the future to make a positive difference for our climate as well. And finally, I'd like to say a big thank you to our speakers, to Kat and Kate for sharing their stories with us. And thank you to all of you for joining. All that's left for me to say is thank you very much for taking part today. I hope you've enjoyed it, and I hope you enjoyed the rest of World Space Week. Goodbye, everyone.